Hi everyone, today I'm gonna show you how to create a game with mouse input in Unreal Engine 4 game engine. Probably we can know that Unreal Engine already have many input templates. It's first person when we're looking from character's eyes. We have most popular third person when camera looks on character's body and game input works from WASD buttons. Also we have top-down template with input like in the Diablo game. But today I'll show you how to create game template when you click right mouse button and hold it to look around. With help mouse wheel, we will able to change distance between camera and character. And our character will go to our target point on landscape, created from left mouse click on this landscape. This input type we can know from the Lineage 2 and many another games. How we can see, I have already opened Unreal Engine 4 project browser window. Here we can select between blueprints, visual scripting system and standard C++ programming language. Today we will use blueprints. Down here we can select starter template. We can use only any of them, even blank, but we will start with top-down and modify it to the condition we need. On next area, we can select project type between PC and consoles and between mobility devices. Then we can choose graphics quality level for our project. Here we can take starter content to our project or don't. The starter content is some standard texture pack with glass, grass, asphalt, wood, gold and other materials. Then we can write path to project folder. Next, I can name our project. I use mouse project name because it's test project for this tutorial. When we ended setup, we can push create project button. I wanna say thank you to our Patreon sponsors for sponsoring our project. When project help is loaded, we can see Unreal Engine 4 interface. When we press play, we could see game mode like in the Diablo game. Our character go to our cursor when we hold left mouse button. Let's set up our project. First, I want to push this button to open a folder structure in the content browser. Then, when I press play, our game opened in this selected viewport. I wanna change it. I want our game opening in new window. I push this button and in drop-down list change option from selected viewport to new editor window. And now our game will open in new window. Next, I wanna change default game window resolution. Actually, we always can resize window size, but I want to set this as default. I open this drop-down list, push Advanced Settings button, and in open window I change default window resolution. like that, and I close this window. After, I want to enable in-game full dynamic lightings. As default, project has stationary lightings. Stationary lightings make us, after any change in level, rebuild lightings. Without rebuilding, we'll have new level with old shadows. To rebuild lightings, we must push this little arrow and push Build Lightings Only button. Full dynamic lighting, different from stationary lighting, in that full dynamic lighting renders shadows in real time, but it's load more system resources. But for now, it's easy to any middle budget PCs. To enable full dynamic lighting, we have to select light source and skylight in the World Outliner window and change mobility option from stationary to movable. Like this. Light source is directional light. How we can see now, shadow start works in real time. After we activate full dynamic lighting, I want to delete all objects we needn't. First, I delete these all cubes. We don't need them. 4 of them we can leave. Next, let's talk about another object in our level. 4 cubes, 4 walls. Then we can see post-process volume. It's some volume to modify video graphics. For now, we doesn't need it. I will delete it. Next, we can see light mass importance volume. It's volume to set some priority lightings render. But for now, we doesn't need it, and I will delete it. Then we can see atmospheric fog component. This can give your outdoor levels a much more realistic look, but we doesn't need it. Next, I delete these words. Then I want to delete sphere reflection capture. This component helps us to make much realistic reflections, but for now we doesn't need it and I delete it. And for now we have only components we need. Let's talk about navigation mesh bounce volume. In this template, our inputs works not with WASD and native movement component inside character, but with simple move to location function, which use AI blueprint helper library, and AI for movement must have navigation volume. If we open Show menu and activate navigation or press P button, we can see green navigation area when our character can go to. Actually, now mesh bounce volume creating this green area. And we have recast now mesh default, which created automatically when we put now mesh bounce volume to our level. Let's try move now mesh bounce volume on right side of our level and press play. Like this. Now we can walking right side of the level when we have now mesh bounce volume, and green area, but we cannot go to left side when green area doesn't exist. For example, let's delete this navigation mesh bounce volume and recast now mesh default, and now our character not have ability to move. If we want to create now mesh bounce volume again, we can search here for now mesh and drag and drop it to our level. If we move it a little bit lower, we could see how volume render green area. Then we can change mobility option from stationary to movable. Movable now mesh can render when character can move in real time. This option can help us when in-game we have many destructible objects, and before we destroy some house, for example, we can move through it, but after we can't. After drag and drop, we can resize our now mesh bounce volume. Oh, it's a little bit bigger than we need. Let's try 50. Let's try 30. Yep, it's okay. Then, let's go inside our character blueprint and talk how it works. Let's open top-down BP folder, then Blueprints subfolder and open up. Let's open in full screen. And let's talk about logic we have. In Components window, we could see two cameras, standard camera and VR camera, virtual reality camera. And on right side of the screen, we can see that all these two cameras have disabled auto activate checkbox. But in event graph, we can see logic which activate one or two cameras on the begin play event. Begin play is event which start when character start game. Is head mountain display enable function tell to the branch it's true that we have connected virtual reality headset. If it's true, branch call the true executable pin and activate VR camera. But if it's false, the branch activate standard camera. Because our tutorial won't have VR support, we don't need VR camera and we just delete all this logic. When we delete camera activation logic and no one camera have auto activate, we can see that we don't have any camera in game now. To fix that, we have to select standard camera and set auto activate checkbox. Now all works correctly. Then I delete virtual reality camera component. Then I select the VR spring arm component. This is kind of arm that hold the deleted VR camera, and we delete it too. We doesn't need it anymore. Then go back to the event graph, and how we can see 90% of logic we have are to VR camera. Because we has been deleted VR camera, we don't need it anymore. I delete it. Down here, we have logic to hold in the green circle to our mouse cursor. It's don't need for us, and I delete this logic. I will delete it. This part we deleting too. Here we have one more logic to VR camera. We delete it. Here we can find the cursor to world component. It's actually our green circle which was holding to cursor. We delete it. Then we press play, and how we could see, we doesn't have any green circle on the mouse cursor anymore. Then I want to set up camera to condition we need. I select camera one more time. How we remember, I activated the auto-activate checkbox in past. Then I select spring arm. It's kind of arm that holds our camera. And we can see that angle we default looking on character. I want to change default value from minus 60 degree to minus 20 degree. Next, we can see the target arm length value. This one define distance between camera and character. Default target arm length value I want to change from 800 to 500. Let's test that. I press play, and as we can see, angle and distance between camera and character has been changed. If we want change center of camera looks from center of character to character's head, we anytime can select spring arm component and change the location parameter from 0 to something like 30 or 40 or 50. As you want. On viewport, character move a little bit down and camera looks on his head. You can do this if you want. I like when camera looks on character center, and I will cancel my changes. Next, I want to remove this cross mouse cursor, this cross image. To do this, we have to open top-down controller inside our folder. Then select class defaults, and in mouse interface area on the right side of the screen change default mouse cursor value from crosshairs to default. I'm saving. Here we have some errors because we deleted cursor to world component from character blueprint, so we can delete this logic. We don't need it anymore. Then I press play, and we can see standard Windows mouse cursor. Now I'll show you how to define custom hardware cursor from custom image. We must go to the content browser and create here a new folder with name as slate. Is important, slate. It's system name. It's very important. That folder name must be slate. Then we have to do right mouse click on this folder and in context menu push show in Explorer button. Like this. And this is very important that we must copy our cursor's image in slate folder open in Windows File Explorer, now not in Engine content browser. Here. I already prepared cursor image. I can open this image in Paint, and we can be sure that is simple PNG format image. Then I'll copy cursor image to the slate folder, and I want rename it to cursor png, just cursor png. Like this. We go back to Unreal Engine. Here we click import or not, it doesn't matter. Then we have to push edit button and in drop-down list select project settings. Here in search box we can write cursor and find hardware cursors and software cursors menus. Difference between hardware and software cursors that hardware cursors works great. Your game have low FPS, frames per second. Here we add one new hardware cursor and set this as default. And in next text box we have to write a path to our cursor. We have a slate folder and cursor as name of the image file. I write slate /cursor. And we don't need to write .png part, just slate /cursor. I can press play and we can see that we already define our own custom cursor. It looks great. And it works correctly. Now I think that we don't need to see this green area from now mesh bounce volume. We can disable it in show menu or just press P button on our keyboard. I want to show you my graphics settings. I push settings and in drop-down list select engine scalability settings. Now on the screen you can see my graphics settings. I have not much powerful GPU video card, and just because I can't select full graphics. And another thing that I don't like this post-processing standard settings. Next, I want to do is create logic to change distance between camera and character from using mouse well up and well down. Now we have a fixed distance value. In character's blueprint, in spring arm component, we have a target arm length parameter. I want to create ability to change it in a game. We can see how looks 1050 value. Let's start. I go to the event graph and I want to take two input events, mouse well up and mouse well down. I do right mouse click and write here mouse well. Here we can see up and down events. I call to these events to increment and decrement distance between camera and our character. Then I take spring arm component and call to set target arm length variable. Connect executable pin from event to set variable. we have to create logic to increment target arm length variable from mouse well down event. How we can do that? We have to read target arm length value, increment it, and write to target arm length variable again. You can define any value of increment, but I want to define 100. If we want to define minimum and maximum distance between camera and character, we can use clamp function to set value limits. Connect a return value to set target arm length variable and define min and max values. It can be 200 and 600 as you want. Don't forget to define a default value when you go into the game. Actually, to decrement part of our logic, we can duplicate our increment logic and just replace increment function to decrement function, as you can see on the screen. We connect it and write here 102. If I open the game, now I have ability to change distance from camera to character. Don't see that I have some lags, it's because my mouse well is little bit broken. It looks great. If you want to invert it, you can replace up and down events. This and this. Now I want to press C button and make a comment to know this code area are to changing camera distance. You can see Russian words because it's translated from Russian videos, my Russian videos. I can start game one more time and be sure that all works correctly. Next, I want to create logic to have ability looking around our character when I press right mouse button and hold it. First, I take right mouse button click event, which calling when we press right mouse button. I'm looking for right mouse button click. All logic we need, we can create inside the event graph, but I want to have clear code and I want to do this in a macro. Macro is the same that the event graph, but we will realize encapsulation as part of object-oriented programming. Then I create a macro and name it as camera movement rotation. Camera movement rotation. Then I create in macro 3 executable input parameters. As I said, it have to be 3 executable pins. First, I will name it as event tick. First, event tick. Second, I call as RMB pressed. I copy, paste it, and the last one I call as RMB released. RMB is right mouse button. Yeah. RMB pressed is right mouse button pressed. And RMB released is right mouse button released. Then we go back to the event graph, call this macro and connect it. Press it to RMB pressed and release it to RMB released. Then call event tick event. And connect event tick event to event tick input parameter through sequence. Sequence we use just because in future event tick will need to us many times. Event tick will need to us too many function in future. After that, inside macro we have event tick. Event tick calls every frame. If we have 60 FPS, we have 60 times per second calling event tick. RMB pressed calls one time we push right mouse button. And RMB released calls one time when we stops holding right mouse button. What next? Next we call the gate function. Like this. Event tick I connect to the enter, RMB pressed to the open and RMB released to the close on gate. Next, we have to create new function with name camera movement. Then I take new camera movement function and connect it to the exit pin on the gate in our macro. How works this logic? By default, the gate is closed, and the event tick don't move through the gate from the enter to the exit. By default, it's closed. We can see checkbox. But when we press right mouse button, calls RMB pressed pin, and the gate opens. Event tick go through the gate to the camera movement function, and we can move our camera, we can look around our character. Then we stop holding right mouse button and release it. RMB pressed pin calls and close the gate. And we lost ability to move camera. Let's create logic inside camera movement function. First, we have to call spring arm component. When we rotate spring arm, we rotate our camera. Take spring arm component and calls set world rotation function on it. Connect it. New rotator is the structure from 3 float type parameters. We can click split struct pin and be sure to that. We can split struct pin or call make rotator function. It's the same thing. And when we set these 3 parameters, we change spring arm rotation and it change rotation of our camera. And actually we can look around in our game. What's next? Next, we calling the spring arm component one more time. Then call get world rotation function on it. Then call break rotator function, or we can split struct pin if you want. It's the same. We don't need to change X axis, so we connect it directly. What about Y and Z axis? We need to change it on mouse direction. Here we must call get mouse X function and get mouse X function. or y function, like this. These two functions giving us mouse direction value. Next, we take current y-axis value from SpringR component and increment it on multiply value of y-axis mouse direction and multiplier. We will multiply y-axis mouse direction value by 5 because direction value by default is too small, and connect all these pins. The same work we do with x-axis part. We can copy that, paste and connect it. Like this. And connect it. Compile and save. We done 99% of this function. Let's test it. As we can see, when we don't hold right mouse button, we don't move camera rotation and we don't look around. But when I press right mouse button and hold it, I can change camera rotation and look around, like this. It works. But as we can see, our camera goes through the landscape, through the floor. It's happening because in SpringR component we don't activate Do Collision Test checkbox. Now, camera don't go through the landscape. As we can see, when we don't do extra values of rotation, all works fine. But when we do extra rotation, all our rotation will broken. You can see this on your screen. To fix this problem, we have to define minimum and maximum values of rotation. We have to do this from y-axis. To do this, we have to take the clump function, and here we can define minimum and maximum values. We are using clump on y-axis only. We doesn't need to do this with x-axis. And connect it. Compile and save. How we can see now, all works correctly. It's great. It's pretty great, I think. It's minimum and maximum values. Yeah, this is minimum value and this is maximum value. Extra values we cannot define. I press play one more time. Let's thinking what more we need. As we can see, when we press right mouse button, hold it and looks around, mouse cursor is still on the screen. I want to create logic when we press right mouse button and cursor will hide. Let's go back to the camera movement macro. And let's create a new function with ability to hide and show mouse cursor. I create new function Name it as show / hide mouse cursor. Show mouse cursor. I open it up. Then I define one new Boolean input parameter and name it as hide. Call it as hide. Yep. Then I take branch, connect it. Then we will set active hide checkbox function will hide cursor. And when hide checkbox will be disabled, function will show cursor. Actually, we can create two functions, but I want one. Here we will connect this function. This function will be calling twice, one time when we press the right mouse button and one time when we release it. But when we pressed, we will define function on hide mode. And when we release function, we will show mouse cursor. To showing, we disable this checkbox. Like this. Let's go inside function. We will start with the hide mode part. First of all, we must take reference to our player controller. Get player controller function. We call it. And our controller reference, we have to call set show mouse cursor variable. On hiding part of our function, we define set show mouse cursor as disabled to hide. And I want to create logic when mouse hide, we are save mouse position on the screen to variable. And when we will show mouse cursor, I want to define saved mouse position on the screen. To realize that, we have to call get mouse position function on controller reference. Next, I want to create a new variable and call it as mouse position. Mouse position. I'll define a variable type as vector2d. Vector2d is a structure from two float type variables. I call this variable toSet, like this. We can call make vector2d function and connect it. Or we can just split struct bin and connect directly. When we activate hide checkbox, the branch should call the true executable pin. Then hide cursor and save cursor's location to the variable. Compile, save, and to the end of function logic we call the return node. We're done with the hide part of logic and let's create show part logic. We can duplicate player controller reference and set show mouse cursor function logic. Then on controller we call set mouse position function. Set mouse position and connect it. Connect executable pins. Don't forget activate show mouse cursor checkbox because it's we're creating a show part of this function. Let's do this clearly, like this. When we have to define to set mouse position function over saved values. I call set mouse position variable split struct pin and connect it. It's easy. On this time, we can done this function. But for future, I want to tell you one feature. When, in future, you will have a widget in your game, when this function will show cursor, your widget won't be active. And you be need twice click to your widget to interact with it. And now I'll show you how to fix that problem. To fix that, we need to call one more function. Function set input mode, game and UI. Connect player controller. To this pin, you will define your future widget. And very important, we have a remove hide cursor during capture checkbox. Let's see how it's worked with active hide mouse during capture checkbox. After one time looks around, cursor starts hide when we pressing left mouse button. We pressing left mouse button and our cursor is hiding. Cursor hide when we press left mouse button. To fix that problem, we have to remove hide cursor during capture checkbox. As we can see, now I press left mouse button and my cursor is still here. And after that, we call return node. Like this. Now we're done with this function. Let's comment this part of logic. This part is showing cursor, and this part is here we hide cursor. When we press RMB this function hide cursor, right mouse button, and when we release RMB function show cursor. Not hiding, it's showing. Now, when we press right mouse button and hold it, we can look around. And our character go to the location we clicked left mouse button. We are done with 90% of tutorial, but I want to change one more thing. Now, I can press and hold left mouse button and character will follow our cursor. Like in Diablo game. I want to change this system. I want to do one left mouse click and create one target point in clicked location. And character will move to this target point. To do this, we have to go inside the player controller, and we can see all this logic template are 2D VR and touch input. We doesn't need 99% of this logic, we will delete it. All of this using to touchscreen and the virtual reality logic. We don't support it. We will need these two functions only. Get hit result under cursor by channel function give to us hit with the location under mouse. This hit go to move to hit location function. Here we take location and put it to the simple move to location function. After that, character move to location we clicked. All this logic is for calculation minimum click distance. When I will click it under our cursor, wait, I disable it. I need to enable it. Moment, I will enable it again, like this. These have a next logic. When a distance between character and click and location less than mean click distance, we won't move. Here, function calculate take these two locations, check it, and if distance between character and click and location less than mean click distance, branch don't let us move. Value of minimum click distance are inside this variable. If we disable this logic, actually I don't see any really difference, but we won't delete it. Let's go back to the event graph. I want to delete all this logic. And then I just call left mouse button event. Left mouse, like this, and connect it. Now, character don't follow cursor anymore. But we just click on same location and character move to. After that, we need to creating a target point objects on the clicked location. I want to see some object on clicked location to see target point we move to. I go to the top-down BP folder, blueprint sum folder, and create here new actor class. Call this as target point. Target point. Like this. Open it up. I should add one new sphere component and name it as target point 2. Then I set this sphere as default root component in this object. Then I want to reduce scale of this sphere. I think it's bigger than we need. I define new scale as 0.4, 0.4 and 0.4. Compile, save. Then we need to disable sphere collision. Here we can do this. Block all dynamic, I change to no collision. Generate overlap events, we can disable too. We don't need it. Compile and save. Here we already done. If we want to define some different material or some visual effects, we can do that, if you want. Let's create minimum required functionality. When we're done here, we can go to the event graph. I want to create self-destroy logic when we create target point wait 3 seconds and destroy itself. To do this, we have to call the delay function on the begin play event. Then set delay time as 3 seconds, for example. And then, after delay, we call the destroy actor function. Destroy actor. Let's test it. I drag and drop target point to the level, press play, wait 3 seconds, and it's deleted. And it's pretty great. Then we need create logic to create target points automatically. I want to create one new function and call it as spawn target point. Spawn target point. Like this, compile, save. Then I want to copy this get hit result under cursor by channel. I press Ctrl plus C, paste here. Then we will break hit result. Then I take the location pin and search for a spawn actor from wait, something wrong. Not here. Here. I search for spawn actor from class function. Connect pins. Then I want to split transform struct pin and connect location to the spawn transform location. Location to the spawn. And at the end, we have to define actor to spawn. Here we must put our created target point object. Compile, save. And we almost done. We need to connect this function when we clicking to location. Drag and drop. And when we press left mouse button, except that we move to location, we create target point. I press play, and how we can see, then we click to landscape, we create target point. Then I want to reduce target point scale. It's bigger than we need. I want something like 0.3, 0.3 and 0.3, like this. A collision we set as always spawn, ignore collision. Compile, save, press play. As we can see, now we have the good scale. But I want to spawn target point a little bit higher landscape. Not inside landscape. To realize it, we have to increment location vector z exists by something like 30. Increment it, connect it, and z exists responsible for height, like 20 or something like this. Now I press play, and we can see that we click into landscape and all works great. When target point has been spawned, after 3 seconds of delay, they are destroy itself. Like this. Then I want to tell you some very important information I've been remembering right now. When we go back to character blueprint into the hide show mouse cursor function, here in set input game mode function, we can see mouse lock mode parameter. I forgot to tell about it, but this parameter is responsible can or cannot our mouse move outside game window. When I select always lock and open the game, our cursor lost ability to move out the game window. Except this, we press and hold right mouse button to look around, we cannot move mouse too long. I can feel a kind of invisible barrier. To fix that, we have to define mouse lock mode as do not lock. And now it's worked correctly. First time, because we hide and show cursor, we also can feel this invisible barrier. It's because by default game engine have a lock mouse mode. We can change it in general settings. In general engine settings. To fix that, we can or define default engine settings, as I say, or call this function on begin play event too, with no lock parameter. Let's do this on controllers begin play event. I call begin play. I call this event and call this function. To controller parameter we put self because we control it. Define as do not lock. Compile, save, then I start game and be sure that all works great. Now we don't feel any invisible barriers. It was the important information. So we're almost done, but I want to show you how to create some interesting material for our target point. I close it. Here I want to create a new material and name it as m_target point. Target point, like this. Open it up. Then I want to import here one texture which I was prepared before this tutorial. I open this file. We can open it and be sure this is a simple PNG image. It's for example only. Next, I drag and drop and import this image to the Unreal Engine 4. Then I drag and drop this texture to our material. Then I search for the panner function. Panner will move our texture. I define panner speed parameters as 1. Then connect panner to the texture's UVs and RGB pin from the texture I connect to the emissive color. Wait for shaders compilation. As we can see now, our texture are moving. It's a little bit interesting. I save it. Wait. Then close it. Then go to the target point, select sphere component, press material and in drop-down list find and define our material. Here. Press compile, save. I press play and we can see our new target point's material. Now we are done with technical part of this tutorial. Today I show you how to create input template with mouse control in Unreal Engine 4. We can press right mouse button and look around. Which mouse will help, we can change camera distance. And when we click on the landscape, we're creating the target point and character move to it. As you can see, we can create target point on walls. It's happening just because we haven't set up collision yet. To best imagine how it works in real game, I want to create little level, change character mesh, and add some footstep sounds. To do that, I'll use next assets: environment set, fantasy mid-level architecture, and the footstep with blueprint. Now I created little level like in real game. Now I can move camera, walk on the road and change camera distance as well. We can go deeper inside this forest. Our character goes through the forest. After that, we always can go back on the road. We are going. Вот мы идем. Now you can see how your game looks like. Here you can see how your game can looks like. Now we came to the house. We have the character. We can go inside house. We can change camera distance. So we already done with mouse style input template. That's all for today. If you like this video, don't forget to like, subscribe, hit the notification bell. If you have some questions, you can ask it in comments. I'll try to give you an answer. And see you next time.